This lesson will show examples with adding probabilities. Let's say I am drawing a poker card. What is the probability that it is red or black? So the first thing we have to determine is whether or not these two events are mutually exclusive. Can these events happen at the same time? We're going to say that a card cannot be both red and black. So that means that these events are mutually exclusive, meaning we can just add up their separate probabilities. So the probability of red or black is equal to the probability of red plus the probability of black. Now, since half of the cards in the deck are red, the probability of that is 1/2. And again, same with the black, probability 1/2. When you add those together, you get a probability of 1. And if you think about this makes sense because all of the cards in a poker deck are either black or red. So you're definitely going to get a card that's black or red. I'm drawing another poker card. Now, what is the probability that it is red or a queen? In this case, a card can be both red and a queen. So they are mutually inexclusive. That means that the probability that a card is red or a queen is equal to the probability that it's red plus the probability that it's a queen minus the probability that it is a red queen. Now, again, half of the cards in the deck are red. 1 out of 13 of the cards are queens, and only 1 out of 52 of the cards is a red queen. So if we calculate the math here, we end up with 29 over 52. Bob bobs for apples in a basket of 1 red apple, 5 green apples, and 44 yellow apples. If he gets a red apple, he wins a graphing calculator. If he gets a green apple, he wins a basic calculator. If he gets a yellow apple, he wins pencil and paper. What is the probability that Bob wins a calculator? Bob wins a calculator if he gets a green or a red apple. So this is just equal to the probability, green or red. Now these events are mutually exclusive because you can't get an apple that is both red and green. So we can just add up their separate probabilities. The probability that an apple is green is 5 out of the total number of apples, 50, and for red it's 1 out of 50. So we end up with a total probability of 6 out of 50, or a 3 out of 25 chance that Bob wins a calculator. I randomly draw a number from 1 to 72. What is the probability that it is divisible by 2 or 3? These events are mutually inexclusive because some numbers are divisible by both 2 and 3. So if we want to find the probability here, we would have the probability that is divisible by 2 plus the probability that is divisible by 3 minus the probability that is divisible by both. From 1 to 72, half of the numbers are going to be divisible by 2. And 1/3 of them are going to be divisible by 3. Now, what about the numbers that are divisible by both? If a number is divisible by both 2 and 3, then that means that it is divisible by 6. So how many numbers between 1 and 72 are divisible by 6? That would be equal to 1/6 of the numbers. So if we calculate the math here, what we end up with is 4/6, or a 2/3 chance that a number is divisible by 2 or 3.